Hi, this is Dharani Murali and you are watching part 1 of Yes Math series. Under this, in last video, we completed the previous year asked Cbse board question discussion from the second chapter, Polynomials. Okay. In this video, we are going to start with the third chapter from NCERT Class 10 textbook, Pair of Linear Equation in Two Variables. Before getting into the chapter, I would like to share my immense happiness on the successful soft landing of Chandrayaan 3 on the south pole of the moon. So this is a very proud moment of all of we Indians. Now coming to us, we are already on board for our CBSE Board 2024 preparations, and I wish all of you for landing in your dream destination groups in your 11th standard with a grand success. In this video, we are going to move one more step ahead in this journey of success with the starting of this third chapter, pair of linear equations in two variables. Okay? In this video, we will be discussing the introduction part and the theory and the problems part from the exercise 3.1. Okay. For those who are using the previous edition textbooks, the exercise 3.1 is deleted. So this is 3.2 exercise in the previous edition. Okay. Coming to the introduction part, what is linear equation in two variables? Any equation that can be put in the form ax plus by plus c equal to 0, where a, b and c are real numbers and a and b both are non-zero. Okay, a and b both should not be equal to 0, because if that happens, then the variable part of the equation will be completely eliminated and only the constant part will be remaining. So it is necessary that a and b both are not 0 is called as a linear equation in two variables x and y. Okay. Now coming to the solution of this equation, a solution of such an equation is a pair of values, one for x and the other for y, which makes the two sides of the equation equal. Okay. Such a pair of values, one for x and one for y, will be called as a solution of this linear equation. So, every solution of this equation will be a point on the line representing this equation. Okay. We now saw that the linear equation in two variable can be represented as ax plus by plus c equal to 0. Okay. So now, what is a pair of linear equations in two variables? Two linear equations with the same variable x and y, say, here we are taking the two variables to be x and y, are called a pair of linear equation in two variables whose general form can be represented as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. These both together is called as a pair of linear equations in two variables where the coefficients a1, b1, c1, a2, b2, c2 are all real numbers and a1 square plus b1 square is not equal to 0 and a2 square plus b2 square is not equal to 0. This condition we represent here for saying that a and b both should not be equal to 0. Okay. In the linear equation in two variable, we saw that a and b both should not be equal to 0. That condition we are representing here as a1 square plus b1 square not equal to 0, and for the second equation a2 square plus b2 square not equal to 0. Okay. Here in this pair of linear equations, we will get a common solution, that is the solution common for both these equations. Now the types of the solutions are classified into three types. Okay. So pair of linear equation in two variables in which the two lines intersect. The first case we are seeing as the two lines intersect at one point. L1 represents the line of the first equation and say L2 represents the line of the second equation. So in the first case, both lines intersect exactly at one point. So this pair of linear equation has exactly one solution, or we can say that it is a unique solution. Okay. Coming to the second case, the two lines will not intersect at any point and such pair of lines are called parallel lines, which does not have a solution, or we say that in that case there is no solution. The two lines L1 and L2 will be parallel to each other. Coming to the third case, the two lines will be coincident. That is, one line lies over the other line. So it will have infinitely many solutions. These are the three cases for the types of solutions of pair of linear equations in two variables. Okay. Now let's see the graphical method of solution for the pair of linear equations. Okay. For any pair of linear equations, that is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, the types of these two lines can be classified based on the ratios a1 by a2, b1 by b2 and c1 by c2, where a1, a2, b1, b2 and c1, c2 are all real. Okay. Now coming to the types of these lines, the first condition where a1 by a2 is not equal to b1 by b2. The ratio of the coefficients of x variable from both the equations is not equal to the ratio of the coefficients of y variable from both the equations. When this condition is present, these two are intersecting lines and there is exactly one solution which can be called as a unique solution. Okay. Coming to the second type, where the ratios of the variable x, variable y and the constant terms are all equal, that is a1 by a2 equal to b1 by b2 equal to c1 by c2. If this case exists, then the two lines are coincident lines, that is the lines representing these two equations are coincident lines, and infinitely many solutions are present for coincident lines. Okay. Coming to the third case, a1 by a2 equal to b1 by b2 and not equal to c1 by c2. The ratio of the coefficients of the variable x and the coefficients of the variable y are equal, but the ratio of the constant term is not equal to these two ratios. That is what we are representing here. a1 by a2 equal to b1 by b2 and not equal to c1 by c2. In this case, we will call the lines as parallel lines, and the parallel lines and the equations representing the parallel lines does not have solution, or we can say no solution. Okay. Now with this we are completing the introduction part of this chapter and the theory part of the first exercise of this chapter. Okay. The handwritten notes of this theory part I will share in the Instagram, Facebook and Twitter, and you can take it from there. Now we will start with the exercise 3.1. Until then, if you are new to this channel and you are watching for the first time, do subscribe this channel and click the bell icon so that you don't miss any updates from this channel. Coming to the first question of exercise 3.1, the question reads, form the linear equations and find their solutions graphically. Okay. So for the given condition, we have to form the pair of linear equations, and then by plotting it on the graph, we should find the solution graphically. Coming to the first subdivision, the question is that 10 students of class 10 took part in a mathematics quiz. If the number of girls is 4 more than the number of boys, find the number of boys and girls who took part in the quiz. Okay. Now we have to find the number of girls and boys took part in the quiz. Now in the first step, what we will do, we will assume let number of girls be x and number of boys be y. Okay. Now what is given here? 10 students of class 10 took part in mathematics quiz. Okay. So number of girls and boys put together, 10 students have taken part in the quiz. So what we will do? Number of girls plus number of boys is equal to 10, which is nothing but x plus y is equal to 10. This equation I am marking it to be 1. Okay. Now coming to the second condition, what it is given, if the number of girls is 4 more than the number of boys. Number of girls is x and it is 4 more than the number of boys. So y, that is number of boys plus 4. Okay. When we rearrange it by putting the variables on one side and constant on the other side, we get x minus y is equal to 4, which is the second equation in the pair of linear equation. I mark it to be equation 2. Now what we should do? We should take the points for marking these two equations in the graph. So taking the first equation x plus y is equal to 10. First we will put x equal to 0 in this equation. So what will happen when we substitute x equal to 0? We will get y is equal to 10. Okay. So the first point we are getting it to be 0, 10. And now for the second point, what we will do? We will substitute y is equal to 0. Substituting 0 in place of y, what we will get? We will get x is equal to 10. So the second point will be 10, 0. Coming to the second equation, x minus y is equal to 4. For finding the values, what we will do? First we will put y is equal to 0. So what we will get? X minus 0 is equal to 4. So x will be equal to 4. So the first point we are getting here is 4 comma 0. Coming to the second point, if we substitute 0 in place of x, what we will get? Minus y is equal to 4, which is nothing but y is equal to minus 4. The second point we are getting is 0 comma minus 4. Now let's plot these 2 points on the graph. Okay. So for the first equation, what we will take? 0 comma 10 and 10 comma 0. So 0 comma 10 will be here. X is 0 and y is 10. So this point is 0 comma 10 and 10 comma 0 is here, which lies on the x-axis, that is x equal to 10 and y is equal to 0. When we join these 2 points, we will get the equation of L1, that is the first equation's line. Okay. Now coming to the second equation, what are the points? 4 comma 0 and 0 comma minus 4. So 4 comma 0 will be on the x-axis, that is x equal to 4 and y equal to 0, and 0 comma minus 4 will be on the negative side of the y-axis, that is x equal to 0 and y is equal to minus 4. Okay. Joining these 2 points, we will get the line of the second equation, x minus y is equal to 4. Okay, so we are marking it to be L2. Now we are asked to find the solution from the graph. Okay, so these 2 lines are intersecting. So here we can clearly see that these 2 lines intersect at a point 7 comma 3. Okay, so the intersecting point will represent 7 comma 3, that is x equal to 7 and y equal to 3, and here we have taken x to be number of girls and y to be number of boys. Okay, so coming to the solution, we have found out number of girls is equal to x is nothing but 7 and number of boys is equal to y is 3. Okay, so we have formed the pair of linear equation x plus y equal to 10 and x minus y equal to 4, and by plotting these 2 on the graph, we have found out the solution graphically. Okay, now let's move on to the second subdivision of this first question. Here the second subdivision reads that 5 pencil and 7 pen together cost rupees 50, whereas 7 pencils and 5 pens together cost rupees 46. Find the cost of 1 pencil and that of 1 pen. Okay, what are the 2 things that we have to find out here? Cost of 1 pencil and cost of 1 pen. So what we will take? We will assume let the cost of 1 pencil equal to x and let the cost of 1 pen is equal to y. We are assuming in this way. So what we will do? What is the first condition? 5 pencils and 7 pens together cost rupees 50. Now here we have taken cost of 1 pencil is x. Okay. So cost of 5 pencils will be 5x plus 7 pens. So 7 into y plus 7y. So what is given? Cost of 5 pencils and 7 pens together is rupees 50. So this is the first equation we are getting. 5x plus 7y is equal to 50. Coming to the second condition, 7 pencils and 5 pens together cost rupees 46. So what we will get? 7 into x plus 5 into y equal to 46. 7x plus 5y is equal to 46. So these 2 are the equations, or we can say this is the pair of linear equation in 2 variable which we are getting here. Okay. So first part we have completed in this solution, form the linear equations, that we have completed. Now coming for graphical representation, we should take the points for these 2 equations. First equation, 5x plus 7y is equal to 50. If we substitute 0 in place of y, this term will be eliminated. So we will get x equal to 50 by 5 and x equal to 10. So first point what we are getting? 10 comma 0. Coming to the second point, we generally prefer to take such values in which we will get whole numbers as the answers for both x and y. Okay. So in that way, if we substitute 3 in place of x, we will get 5 into 3, 15. So 50 minus 15 would be 35. Okay. So what we will get? Y is equal to 35 by 7, which is nothing but 5. Okay. So what is the second point we are getting? 3 comma 5. So these 2 points we are getting for the first equation, 5x plus 7y is equal to 50. Now coming to the second equation, 7x plus 5y is equal to 46. First we will substitute minus 2 in place of y. So what we will get? 7x minus 10 is equal to 46. So we will get x is equal to 56 by 7. So x equal to 8. So the first point we are getting here is 8 comma minus 2. Coming to the second point, if we substitute minus 2 in place of x, what we will get? Minus 14 plus 5y is equal to 46. So 5y is equal to 46 plus 14, y equal to 60 by 5 and y is equal to 12. Okay. So the second point is minus 2 comma 12. These two are the points for the second equation, 7x plus 5y is equal to 46. Now to find the solution, we will plot all these points on the graph. Now first we will plot the first equation points, 10 comma 0 and 3 comma 5. Whenever we get a y value to be 0 in a coordinate, then the point will lie on the x-axis. So 10 comma 0 will be here and 3 comma 5 will be 3 from x-axis and 5 from y-axis. We will get here at 3 comma 5. Now we will join these two points to get L1, that is the first line of the equation 5x plus 7y is equal to 50, or the first equation. Coming to the second equation, the points are 8 comma minus 2 and minus 2 comma 12. 8 comma minus 2 will be here, 8 from x-axis and minus 2 from y-axis, and minus 2 comma 12 will be minus 2 from x-axis and 12 comma y-axis, we will get it here. Joining these 2 points, we will get L2, that is line of the second equation, 7x plus 5y is equal to 46. Okay. Clearly these two lines intersect at the point 3 comma 5. So 3 comma 5 is the solution of these two lines or these two equations. Since here we have to find the cost of the pencil and pen, we will write the answers in terms of rupees. Okay. So cost of one pencil will be x, that is x value of this coordinate, that is rupees 3. And coming to cost of one pen, it will be y value of this coordinate, that is rupees 5. Okay. With this, we are completing the second part of this solution, that is find the solution graphically. Now let's move on to the second question. Coming to the second question reads that on comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the lines representing the following pairs of linear equations intersect at a point, are parallel or coincident. Okay. So basically they are asking the types of lines representing the given equations by using the relationship between the ratios. Okay. So here in the second question we have 3 subdivisions. Let's see one by one. In the first subdivision, the equations given are 5x minus 4y plus 8 equal to 0 and 7x plus 6y minus 9 equal to 0. From these two equations, first let us find out a1, b1, c1 and a2, b2, c2. Here a1 equal to 5, b1 equal to minus 4 and c1 is equal to 8 and a2 is equal to 7, b2 is equal to 6 and c2 is equal to minus 9. Okay. Now let's find the ratios. a1 by a2 is equal to 5 by 7 and b1 by b2 is equal to minus 4 by 6. This can be simplified and written as minus 2 by 3 and c1 by c2 is nothing but 8 by minus 9. Okay. Now let's compare a1 by a2 and b1 by b2. So here a1 by a2 is 5 by 7 and b1 by b2 is minus 2 by 3 and these two are not equal. Okay. Here while comparing these ratios, if a1 by a2 is not equal to b1 by b2, then we will conclude by saying that the lines are intersecting and the pair of linear equation has only one solution, that is unique. Okay. If a1 by a2 is equal to b1 by b2, then we will proceed for the ratio c1 by c2 to check whether the lines are coincident or parallel. Okay. In this case, it is very clear a1 by a2 is not equal to b1 by b2. So in this first subdivision, this pair of linear equations will be having intersecting lines when represented in the graph. Okay. Coming to the second subdivision, the equations are 9x plus 3y plus 12 equal to 0 and 18x plus 6y plus 24 equal to 0. Here also first we will take a1, b1, c1 and a2, b2, c2 separately and write it down. a1 is equal to 9, b1 is equal to 3 and c1 is equal to 12. That is what we are writing it here. And a2 is equal to 18, b2 is equal to 6 and c2 is equal to 24. Okay. Now let's find out the ratio. a1 by a2 is equal to 9 by 18, that is 1 by 2, and b1 by b2 is 3 by 6, which is nothing but 1 by 2 when simplified, and c1 by c2 is 12 by 24, which is also 1 by 2. Okay, so we will take and write it down here separately. 9 by 18 is equal to 3 by 6 equal to 12 by 24 equal to 1 by 2. So clearly we can see that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So all these ratios are equal. Then we can say that the lines representing these two equations will be coincident and will have infinitely many solutions. Okay. Now let's see the third subdivision. The equations are 6x minus 3y plus 10 equal to 0 and 2x minus y plus 9 equal to 0. Okay. We will write a1 is equal to 6, b1 is equal to minus 3 and c1 is equal to 10. And a2 is equal to 2, b2 is equal to minus 1 and c2 is equal to 9. Okay. Now let's find out the ratios. a1 by a2 is nothing but 6 by 2, that is 3 by 1, and b1 by b2 is minus 3 by minus 1, which is equal to 3 by 1, and c1 by c2 is 10 by 9, which is non-simplifiable. Let's take it down and write it separately. a1 by a2 and b1 by b2 are equal. 6 by 2 is equal to minus 3 by minus 1 is equal to 3 by 1, which is not equal to 10 by 9. That is, a1 by a2 is equal to b1 by b2 and not equal to c1 by c2. When this condition is present, then the lines representing these two equations will be parallel lines and there will be no solution. Okay. So with this we are completing the second question. Now let's move on to the third question. So now in second question we were asked to find whether the pair of linear equations are intersecting, parallel or coincident. Okay, by comparing the ratios a1 by a2, b1 by b2 and c1 by c2. In this third question we are asked to find by comparing the ratios whether the linear equations are consistent or inconsistent. Okay, now coming to what is consistent and inconsistent. Whenever the pair of linear equations have a solution, whether one solution or infinitely many solutions, if it has solutions then it is called consistent, and in the case when they are parallel lines and it has no solution, it is called inconsistent. Okay, now let's see the subdivisions one by one. Okay, first subdivision, the equations are 3x plus 2y is equal to 5 and 2x minus 3y is equal to 7. First we have to put it in the form ax plus by plus c is equal to 0. We have to bring the constant to the same side and we have to represent it in this form. So we will write 3x plus 2y minus 5 is equal to 0 and 2x minus 3y minus 7 is equal to 0. Okay, we will write a1 is equal to 3, b1 is equal to 2 and c1 is equal to 5, and a2 is equal to 2, b2 is equal to minus 3 and c2 is equal to minus 7. Now let's find the ratios. a1 by a2 is equal to 3 by 2, which is already in a simple form, so we cannot simplify it further. b1 by b2 is equal to 2 by minus 3 and c1 by c2 is equal to minus 5 by minus 7, which we can write it as 5 by 7 since the minus sign will get cancelled. Okay, so here we can clearly see that 3 by 2 is not equal to 2 by minus 3. So we can say that a1 by a2 is not equal to b1 by b2. Whenever these two are not equal, we need not move to the ratio c1 by c2. Okay, here itself we can conclude it by saying that these are intersecting lines. It has exactly one solution. So this pair of linear equations are consistent. Okay, now in the second subdivision, the equations are 2x minus 3y is equal to 8 and 4x minus 6y is equal to 9. So first let us put it in the form ax plus by plus c equal to 0. So 2x minus 3y minus 8 equal to 0 and 4x minus 6y minus 9 is equal to 0. Let's write a1 is equal to 2, b1 is equal to minus 3 and c1 is equal to minus 8, and a2 is equal to 4, b2 is equal to minus 6 and c2 is equal to minus 9. Okay, now let us find out the ratios. a1 by a2 is equal to 2 by 4, which is nothing but 1 by 2, and b1 by b2 is equal to minus 3 by minus 6, which is equal to 1 by 2 again, and c1 by c2 is equal to minus 8 by minus 9, which we can write it as 8 by 9. Okay, so here clearly we can see that a1 by a2 is equal to b1 by b2 is equal to 1 by 2. Okay, and it is not equal to C1 by C2. So A1 by A2 is equal to B1 by B2 not equal to C1 by C2. This condition represents the parallel lines and it has no solution. If it does not have a solution, then the pair of linear equations are inconsistent. Okay. In third subdivision, we have equations 3 by 2x plus 5 by 3y equal to 7 and 9x minus 10y is equal to 14. In the first step, what we have to do, we will bring the equations to the form ax plus by plus c equal to 0. So, we will write 3 by 2x plus 5 by 3y minus 7 equal to 0 and 9x minus 10y minus 14 is equal to 0. So, here also we will write a1 is equal to 3 by 2, b1 is equal to 5 by 3 and c1 is equal to minus 7 and a2 is equal to 9, b2 is equal to minus 10 and c2 is equal to minus 14. Okay. Now let's find out the ratios. A1 by A2 is equal to 3 by 2 by 9. Okay. So it will become 3 by 2 into 1 by 9. Here we can cancel out 3 into 3, 9. Okay. So we will get 1 by 6 and B1 by B2 is equal to 5 by 3 by minus 10. We can write it as 5 by 3 into minus 1 by 10. We will get minus 1 by 6 because here also we can cancel out 5 into 2, 10. Okay. So A1 by A2 is equal to 1 by 6 and B1 by B2 is equal to minus 1 by 6. So clearly we can see that A1 by A2 is not equal to B1 by B2. If this is the case, we need not proceed for the C1 by C2 ratio. Okay. Here itself we can conclude by saying these two are intersecting lines and it has exactly one solution or unique solution and the pair of linear equation are consistent. So in fourth subdivision, the equations given are 5x minus 3y is equal to 11 and minus 10x plus 6y is equal to minus 22. Here also we have to bring it to the form ax plus by plus c is equal to 0. So we will bring the constant to the other side and we will write 5x minus 3y minus 11 is equal to 0 and minus 10x plus 6y plus 22 is equal to 0. Here a1 is equal to 5, b1 is equal to minus 3 and c1 is equal to minus 11 and a2 is equal to minus 10, b2 is equal to 6 and c2 is equal to 22. Okay. So we will take the ratios a1 by a2 is equal to 5 by minus 10 which is equal to minus 1 by 2 and b1 by b2 is equal to minus 3 by 6 which is also equal to minus 1 by 2 and c1 by c2 is equal to minus 11 by 22 which is also minus 1 by 2. Here we can clearly see that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. If this condition is present, then we can say the lines are coincident and the pair of linear equations has infinitely many solutions. So this pair of linear equations is consistent. Now coming to the fifth subdivision, the equations given are 4 by 3x plus 2y is equal to 8 and 2x plus 3y is equal to 12. Here also first we will put these equations in the general form ax plus by plus c equal to 0. So we will get 4 by 3x plus 2y minus 8 is equal to 0 and 2x plus 3y minus 12 is equal to 0. Here a1 is equal to 4 by 3, b1 is equal to 2 and c1 is equal to minus 8 and a2 is equal to 2, b2 is equal to 3 and c2 is equal to minus 12. Okay. We will take the ratios a1 by a2 is equal to 4 by 3 by 2. So what we will get 4 by 3 into 1 by 2, we can cancel it out like this. So we will get 2 by 3. And coming to b1 by b2, it is 2 by 3 and c1 by c2, it is minus 8 by minus 12. When the minus is present in both numerator and denominator, it can be cancelled out and it is 4 into 2, 8 and 4 into 3, 12. So we will get 2 by 3. Here we can clearly see that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So these two lines are coincident and this pair of linear equations has infinitely many solutions. If this is the case, then the pair of linear equations is consistent. Okay. With this subdivision, we are completing the third question. Now let us move on to the fourth question. In third question, we found whether the given pair of linear equations is consistent or inconsistent based on comparing the ratios. Okay. In fourth question, they are asking which of the following pairs of linear equations are consistent or inconsistent. If consistent, obtain the solution graphically. Okay. Here, first we have to find whether the given pair of linear equations are consistent or inconsistent. If consistent, we have to find the solution graphically. Okay. In the first subdivision, the equations given are x plus y is equal to 5 and 2x plus 2y is equal to 10. So first we will bring it to the form ax plus by plus c is equal to 0. So we will get x plus y minus 5 is equal to 0 and 2x plus 2y minus 10 is equal to 0. Okay. So here a1 is equal to 1, b1 is equal to 1 and c1 is equal to minus 5 and a2 is equal to 2, b2 is equal to 2 and c2 is equal to minus 10. Okay. We will find the ratios now. a1 by a2 is equal to 1 by 2, b1 by b2 is equal to 1 by 2 and c1 by c2 is equal to minus 5 by minus 10, where the minus will get cancelled and 5 into 1 5, 5 into 2 10. So we will get 1 by 2. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to 1 by 2 here. Okay. So all these ratios are equal. So we will say the lines will be coincident and the equations will have infinitely many solutions. If the equations have solutions, then the equations are consistent. So what are we asked here? If consistent, obtain the solution graphically. To obtain the graphical solution, we will first find the points for these two equations. For x plus y is equal to 5, if we put x equal to 0, we will get y equal to 5, and if we substitute y equal to 0 and we will get x equal to 5. Okay. Coming to the second equation, in 2x plus 2y is equal to 10, if we put x equal to 0, we will get y is equal to 10 by 2, which will be nothing but 5. And if we put y is equal to 0, then we will get x equal to 10 by 2, which is equal to 5. If we clearly see here, in both the cases we are getting the points 0, 5 and 5, 0. Just now we have found that the lines representing these two equations will be coincident. Okay. If it is coincident, then we can say that these are overlapping lines. The lines are one over the other. So the points will be same in both the cases. Now let's plot the lines. 5, 0 will be here on the x-axis and 0, 5 will be here on the y-axis. So this represents both L1 and L2. Okay. Since these two lines are coincident. Okay. Now let's move on to the second subdivision. The equations given are x minus y is equal to 8 and 3x minus 3y is equal to 16. Okay. First we will bring it to the form ax plus by plus c equal to 0. So x minus y minus 8 equal to 0 and 3x minus 3y minus 16 is equal to 0. Here a1 is equal to 1, b1 is equal to minus 1 and c1 is equal to minus 8. And a2 is equal to 3, b2 is equal to minus 3 and c2 is equal to minus 16. So we will find the ratios now. a1 by a2 is equal to 1 by 3 and b1 by b2 is equal to minus 1 by minus 3, which will be simplified to 1 by 3, and c1 by c2 is equal to minus 8 by minus 16. So minus will get cancelled and 8 by 16 is equal to 1 by 2. So here we can see a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Whenever we get this condition, we can say that the lines representing these two equations will be parallel and there will be no solution. If there is no solution for these two equations, then the pair of equations are inconsistent. Okay. Here we need not proceed further because it is asked if consistent, we have to find the solution graphically. So here it is inconsistent, so we are stopping the solution here. Now let's move on to the third subdivision. Now in third subdivision, the equations given are 2x plus y minus 6 equal to 0 and 4x minus 2y minus 4 equal to 0. This is already in the form ax plus by plus c equal to 0. Okay. So directly now we will take the values. a1 is equal to 2, b1 is equal to 1 and c1 is equal to minus 6 and a2 is equal to 4, b2 is equal to minus 2 and c2 is equal to minus 4. Okay. Now we will take the ratios. a1 by a2 is equal to 2 by 4 is equal to 1 by 2, b1 by b2 is equal to 1 by minus 2 and c1 by c2 is equal to minus 6 by minus 4, which is nothing but 3 by 2. Here we can clearly see that a1 by a2 is not equal to b1 by b2. Okay. If this condition is arising, then we can say that the lines representing these two equations will be intersecting and there will be exactly one solution. Okay. If there is a solution for these two equations, then we can say these equations are consistent, and here it is asked if consistent, we have to obtain the solution graphically. Now to plot the graph, we are taking the points. For the first equation, 2x plus y is equal to 6. If we substitute y equal to 0, we will get x equal to 6 by 2, which is nothing but 3. If we substitute x equal to 0, we will get y is equal to 6. Okay. Now coming to the second equation, 4x minus 2y is equal to 4. If we put x equal to 0, we will get y equal to 4 by minus 2, which is nothing but y is equal to minus 2. And if we put y is equal to 0, we will get x equal to 4 by 4, which is nothing but 1. Okay. Now we will plot all these points on the graph to get a solution. For the first equation, 3, 0 and 0, 6. 3, 0 will be here on the x-axis and 0, 6 will be here on the y-axis, and we will join these 2 points and we will write it as L1, or the line of the equation 1. Okay. Coming to the second equation, the points are 0, minus 2 and 1, 0. 0, minus 2 is here and 1, 0 is here. If we join these 2 points, we will get a line and we will mark it as L2, that is line of the second equation. Now, if we notice, these two lines intersect at this point, which is 2, 2. Okay. So the solution for these two equations is x, y is equal to 2, 2, or we can specifically say x equal to 2 and y is equal to 2. Here we have got it as intersecting lines, so exactly one solution or unique solution exists, which is x equal to 2 and y equal to 2. Now let's move on to the next subdivision. In fourth subdivision, the equations given are 2x minus 2y minus 2 equal to 0 and 4x minus 4y minus 5 equal to 0. This is also already in the form ax plus by plus c equal to 0. Now we will take the values. A1 is equal to 2, B1 is equal to minus 2 and C1 is equal to minus 2. A2 is equal to 4, B2 is equal to minus 4 and C2 is equal to minus 5. Okay. Now if we take the ratios, A1 by A2 is equal to 2 by 4 equal to 1 by 2 and B1 by B2 is equal to minus 2 by minus 4, which is also 1 by 2, and C1 by C2 is equal to minus 2 by minus 5. So we can clearly say that A1 by A2 equal to B1 by B2, not equal to C1 by C2. This condition represents that the lines representing these two equations will be parallel and there will be no solution. If there is no solution, the pair of linear equations is inconsistent. Okay. With this subdivision, we are completing the fourth question. Now let's move on to the fifth one. Now in fifth question, it is asked that half the perimeter of the rectangular garden, whose length is 4 meter more than its width, is 36 meter. Find the dimensions of the garden. Okay. So it is given, it is a rectangular garden. So we will take, let length equal to x and width equal to y. Okay. So what are the data that is given? Length is 4 meter more than its width. Okay. So length x equal to 4 meter more than its width, that is 4 plus y. If we rearrange this, we will get the equation x minus y is equal to 4. Okay. What is the next data given? Half the perimeter of the rectangular garden is 36 meter. Okay. What is the perimeter of the rectangular garden? 2 into L plus B. Here we have to take half of that. So 2 into L plus B by 2, which is nothing but x plus y. Here half the perimeter is given to be 36 meters. So we will get x plus y is equal to 36. Okay. So we have got two equations, x minus y is equal to 4 and x plus y is equal to 36. Now to find the dimensions of the garden, that is length and width, what we will do, we will find the points for plotting and we will plot it on the graph and find the solution graphically. Okay. So for the first equation, x minus y equal to 4. If we put y equal to 0, we will get x equal to 4. And if we substitute x equal to 0, we will get y equal to minus 4. Okay. Now coming to the second equation, x plus y is equal to 36. If we put x equal to 0, we will get y equal to 36. And if we put y equal to 0, we will get x equal to 36. Okay. So now we will plot these things on the graph. For the first equation, the points are 4, 0 and 0, minus 4. So 4 comma 0 will be here on the x-axis and 0 comma minus 4 will be here on the y-axis. Now if we join these 2 points, we will get a line. We will mark it as L1. Okay. Now coming to the second equation, the points are 0 comma 36 and 36 comma 0. So 0 comma 36 will be here on the y-axis and 36 comma 0 will be here on the x-axis. Okay. If we join these 2 points, we will get a line. Let's name it L2. Okay. These two lines clearly intersect at this point, which is nothing but 20 comma 16. 20 from x-axis and 16 from y-axis. Okay. So what we have assumed at the beginning, length equal to x and width equal to y. Here in this intersection point, x equal to 20. So here length equal to 20 meter and here y is equal to 16. So width is equal to 16 meter. This is the dimensions of the rectangular garden. Okay. This is the required solution for this question. Length equal to 20 meter and width equal to 16 meters. Okay. Now coming to the sixth question, it is asked, given the linear equation 2x plus 3y minus 8 is equal to 0, write another linear equation in two variables such that the geometrical representation of the pair so formed is. So for this given linear equation 2x plus 3y minus 8 equal to 0, we have to find another linear equation such that in first subdivision, the pair of linear equations involving the given linear equation and the linear equation which we have to find now will be of intersecting lines. Okay. So here for intersecting lines, we know that the condition of the ratio is a1 by a2 is not equal to b1 by b2. Okay. We know that a1 is equal to 2 and b1 is equal to 3. If these two ratios should not be equal, then we can interchange these two coefficients and take the equation keeping the constant same. Okay. This is one of the trick to find the linear equation which will be forming an intersecting line with the given equation. So we can take it to be 3x plus 2y minus 8 is equal to 0. Okay. So that 2 by 3 will not be equal to 3 by 2. Okay. Now coming to the second subdivision, the line representing the given linear equation and the line representing the equation which we are going to find should be parallel. Okay. So what is the condition of the ratios for the lines to be parallel? a1 by a2 equal to b1 by b2 not equal to c1 by c2. If a1 by a2 equal to b1 by b2, then what we can do? We can take this variable part as it is and we can just change the constant such that it is not equal to the other ratios. So what are we doing? We are taking the variable part as it is. 2x plus 3y minus 10 equal to 0. Okay. Here 2 by 2 will be equal to 3 by 3 which is equal to 1 by 1 and minus 8 by minus 10 will not be equal to 1 by 1. So this condition will be satisfied. Okay. Now for finding the coincident line, the ratio should be a1 by a2 equal to b1 by b2 equal to c1 by c2. So here what we can do? We can simply multiply any number throughout this equation on both the sides and write it as it is. Okay. So here I am multiplying it by 2. So we will get 2 into 2 4x plus 6y minus 16 is equal to 0. So the entire ratio will be equal to 1 by 2 because we are multiplying it by 2. So we are getting 1 by 2. Okay. With this we are completing the sixth question. Let us move to the seventh question. In seventh question it is given that draw the graphs of the equations x minus y plus 1 equal to 0 and 3x plus 2y minus 12 equal to 0. Determine the coordinates of the vertices of the triangle formed by these lines and the x-axis and shade the triangular region. Okay. So in this question it is said that we have to draw the graphs for these two equations and we have to find the coordinates of the vertices of the triangle formed by these two lines and the x-axis. Okay. So first we will write these two equations here and we will rearrange it to find the points. X minus y equal to minus 1 and 3x plus 2y is equal to 12. Okay. In first equation x minus y equal to minus 1. If we put x equal to 0, we will get y equal to 1 and if we substitute y equal to 0, we will get x equal to minus 1. Okay. Now coming to the second equation, If we substitute x equal to 0, then we will get y is equal to 12 by 2, which is nothing but 6. And if we put y equal to 0, we will get x equal to 12 by 3, which is nothing but 4. Okay. Now let's plot these points on the graph. For the first equation, the points are 0, 1 and minus 1, 0. So 0, 1 will be here on the y-axis and minus 1, 0 is here on the negative side of the x-axis. Okay. Now if we join these two lines, let's mark it as L1 or the line representing the equation 1. Okay. Coming to the second equation, the points are 0, 6 and 4, 0. 0, 6 will be here on the y-axis and 4, 0 will be here on the x-axis. Okay. If we join these 2 points, we will get the line L2, which is the line representing the equation 2. Okay. Now if we see, the point at which these 2 lines intersect is 2, 3. If we see here, let's mark this point minus 1, 0 as A and the point 4, 0 as B and this intersecting point 2, 3 as C. So here ABC triangle is formed by these 2 lines and the x-axis. So the coordinates of the vertices of this triangle ABC is A minus 1, 0, B 4, 0 and C 2, 3. Okay. And also it is given that we have to shade this triangular region. Okay. So with this, we are completing the 7th question and we are also completing this exercise 3.1. Okay. And in next video, we will continue with the theory part and the problems of exercise 3.2. Until then, if you have not subscribed this channel till now, do subscribe this channel to get the updates time to time. And let's meet in the next video with the continuation of chapter 3 pair of linear equation in 2 variables. Until then, bye bye.